So today in class, we'll be discussing what are called improper integrals. And these are going to be definite integrals, except we're going to see that there's something a little funky about these particular integrals as compared to the ones we've done already this semester. So for example, one example of an improper integral is where we see infinity starting to be in a lower bound or an upper bound in some of these definite integrals. So this is sort of the first kind of improper integral that we'll discuss, sort of where we have plus or minus infinity hanging out on integration bounds. So for example, a few of these integrals could look like these following two examples, where this integral on the left-hand side, the integral from 0 to infinity, 1 over x squared, what we see is a little interesting that we haven't discussed already in this course is how to handle that plus infinity upper bound. Or we could see where negative infinity is hanging out at a lower bound. Or like the case on the right-hand side, what do we do if we see that the integration bounds are across all real numbers from minus infinity to positive infinity? So this is one example of an improper integral, kind of the type 1, where we see infinities hanging out as the integration bounds. The other type of improper integral is when the integrand itself becomes singular somewhere in the integration domain. So maybe it helps to first kind of think about what we mean by singular. And by singular, what we really mean is we get a divide by 0 somewhere. And we get this divide by 0 specifically somewhere within the integration bounds. So for example, an example of these type 2 kind of singular integrals could be something along the lines of, say, -1 to 3, 1 over x minus 2 dx. Now, at a quick glance, there's nothing funky about this integral compared to what we've done already in class, except if we look a little bit closer, we see that this integration domain extends from, well, if we're looking at the real number line, from -1 all the way to +3. However, at x equals 2, we have a problem. We get a divide by 0. And that x equals 2 happens somewhere within that integration domain. So this is something, oops, already noticed some of this video is blocking, but somewhere within that integration domain, we get that divide by 0. We need to handle that somehow. It just so happens all the examples we've done so far in this course, all the definite integrals you've computed so far in your calculus journeys have not had these divide by zeros inside of that integration domain. And the real answer of how we're going to handle these things turns out to be limits in both cases. Limits are going to come in to save the day when we have infinite integration bounds, as well as in the case when the integrand is singular, like this type 2 example we just went through. The other thing we'll be discussing today in terms of improper integrals is we're going to see some new definitions that you may have not seen before for convergent and divergent. We're also going to talk about how we might be able to tell if an integral is convergent or divergent by comparing it to another integral that we know something about. So stay tuned for the next video that has an example of how to handle an infinite integration bound.